Hi Year 9s. So carrying on with our particle model of matter topic, if you remember the first few weeks we were looking at densities, and I got you to carry out a practical at home where you were measuring the densities of regular and irregular shaped objects using that equation, density is mass divided by volume. Then we started looking at states of matter, and we said there are three main states of matter. They're not the only states, but they're the ones that we're concerned with, and that is solid, liquid and gas. And you were drawing representations of solid, liquid and gas. And they'd look like these. So your solid, you would have the particles arranged neatly in nice rows and columns, particles touching each other. And the liquid one, they are randomly orientated now. Majority are still touching each other. Then when you move to the gas, no particles are touching each other. Now in that first one, in the solid one, you've got that strong bonds holding the things together. That's why solids are so tough. And I've got some ice here to show you that. So if we could look inside this ice at each individual molecule of water in there, we would see that they're arranged very similar to this in these nice neat rows and columns. And there's really strong bonds holding them together. Well, how do I get this to be more like a liquid? Well, I have to break those bonds. I have to apply heat. As I apply heat, already you can see it's starting to melt already. It's turned into a liquid. So those strong bonds are breaking. When they are like this, when they are in a solid, they are not stationary, they are locked together, but they are constantly jiggling around. How do I make them jiggle around even faster? I give them energy. I give them, in this case, heat energy. And that heat energy makes them jiggle around faster and faster and faster until those strong bonds are breaking. Then we're just left with the weaker bonds holding them together. I keep heating this up. Eventually I can break the weaker bonds and turn this into a gas. Now, if we were to carry this out in a lab, we'd give this ice a constant source of heat. We'd measure the temperature at each individual time, and we were to plot this on a graph. You may expect it to look a little bit like this, but that is not what we see. We see a totally different shape to our graph than this one. So now if you'd like to go to the PowerPoint, and I'll discuss the shape we get and why we get that distinctive shape. Okay, see you soon.